Okay, let's take a look at today's lesson. So we are spending 2 days on navigation and surveying. Today we are basically going to just look at navigation. We're going to, the next lesson will be on surveying. So let's talk about the way that we measure angles. So my husband is a pilot and we have this disagreement, you know, about the way you're supposed to measure angles. I'm like, well, you're supposed to go from the x-axis and you're supposed to rotate counterclockwise. He's like, no, that's dumb. You're supposed to go from the north line and go clockwise because that's what they do. I'm like, no, that's wrong. And he's like, no, that's wrong. But at any rate, whatever, they're different. They're different. We need to get in our head before we get this on this lesson that they are different. We are not going to be measuring angles like we normally do, like the proper way to do. We're going to be measuring angles from the north line, how navigation is done. So let's look. So we have this particular thing right here. We have, notice that it's in like 110 degrees. That's the course. So this is measured from a north line. It's measured clockwise. It's clockwise. So we go to the north line and we rotate clockwise until we hit the course or the path of the ship. And that measurement in this kind of a situation is 110 degrees. So that's how we do measurements with navigation, is we're measuring from the north line. We really ignore the fact that there even is an x-axis and, you know, the proper way. We don't even do that. So that's different. One of the most difficult things for students on this lesson is bearings. Now the other things students usually, you know, get the hang of it, understand how to do, but for some reason bearings really trouble students. So I'm going to go through them and try to explain the best that I can how to and where to calculate a bearing. So the word that we are looking for is the from word. This is the key to understanding how to draw and figure out what the bearing is. From. We go to the from. So if I want to find the bearing of B from A, I go to the from. Here's my A. I draw a north line. Okay, it's drawn right here. Then I rotate from the north line to the path. That is the measurement of the bearing. If I'm measuring the bearing of B from A, then that bearing is 60 degrees. Now, let's say we want to do a different one. Let's say we want to measure from B. So I go to B, I draw my north line, I go above B on the north line, and I rotate until I hit the path. And so in this case, the bearing of A from B is 240 degrees. So I wrote this diagram here for your reference, hoping that that would be some help to you as you're trying to figure out bearings. Probably most points are lost on a problem like these on bearings. I mean, in general, for quizzes and tests, students really have a hard time with the bearings. So if you just kind of go to the from, draw a north line at the from point, and then rotate clockwise till you hit the path, that's the bearing. Okay? That's kind of as easy as I can make it. There's no other simple way I can think of. So let's go ahead and jump into, we have one example to work. So let's go ahead and go to that example, and it has a bearing in it, so we'll talk more about bearings. Now you're going to have to draw the picture. The picture isn't going to be drawn for you, and this presents some challenge to us. The picture doesn't have to be perfectly accurate, but it's got to be pretty good. We have to be in the right quadrant, going the right way. I mean, you know, it has to be pretty good. So you need space to draw the picture. You need some space, because where we start, we're not really sure where we're going to be going. We're going to go right, we're going to go left, unless we read through the whole problem and try to figure it out ahead of time. So I'm going to start my drawing, you know, right in here. And so let's start reading the example. So we have a ship that proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. Stop. I'm going to stop right there, and I'm going to draw that. So I draw my north line as a dotted line. Do you have to? No. I like to draw it as a dotted line so that I understand that it's not part of the figure. I want to be sure it's not part of the figure, so I do a dotted line. There's my north line. I need a course of 300 degrees. So we start from the north line and we start rotating clockwise. If I rotate down here, that's 180 degrees. That's not enough, right? I keep rotating to this portion, that's 270 degrees. That's not enough. So it's probably going, up like that. Does it have to be perfect? No. We just need, and I probably actually even need to move it over. So let's start a little bit farther over. Okay, so we're here. Here's our north line. Here's our 300 degree course. So I draw this, I indicate that's 300 degrees. And if I'm going 2 hours at a speed of 15 knots, what distance have I covered? 30 knots, right? If I go 15 knots an hour and I've gone 2 hours, then this is 30 knots. So this is 30 nautical miles. Now, a nautical mile is really close to a regular mile. It's kind of cool if you want to Google it sometime. It actually is calculated with the curvature of the Earth. It's not exactly a mile as we, think about it when we're driving, but it's really close. Okay, so that's the first part. We okay so far? Okay, so now let's continue reading. So then we change course to 230 degrees, continuing at 15 knots for 3 more hours. So I stop. I go to where I ended my first path and I draw a north line. So now I need to go 230 degrees. So I start rotating above on the north line. I rotate like this. That's 180 degrees, right? That's not enough. I need 230. So that's going to put us like would be quadrant 3, right? 230 would be right here. So we're going to rotate this way. And notice, let's see what distance. 15 knots for 3 hours. So how far have I gone? 45. I've gone 45 nautical miles. Now I need to make sure that this segment that I draw is longer than this segment. I mean, does it have to be perfectly proportional? No, but it has to make sense, right? It needs to be longer. So I need to be sure I'm drawing this longer than the 30 nautical mile one. So this is 45, and I'm measuring, this measurement right here is 230 degrees. Okay. Then it says at that time, how far is the ship from its starting point? So we want to know this. This distance we'll call x. And what's the bearing from the starting point? Okay, we're going to worry about a bearing in a minute. Let's answer the distance question first. So one reason why we have to draw these diagrams so well is we're going to have to work off of it. We're going to have to read things off of it. And so I encourage you, I wouldn't really mess with this drawing that much. If you need other drawings, I would go to the side. I'm going to look at it and try to calculate measurements, but I'm not going to draw all over it because I don't want to have to start again. Right, so let's look. The north lines are very beneficial to us. You really need to kind of pay attention to them. They would be 2 parallel lines cut by a transversal, right? Geometry. So kind of visualize this for me. If you need to extend the north lines down, you can. I have 2 parallel lines cut by a transversal. First of all, is it possible for me to find this angle measure right here? It is, right? Because this much is 300, and then if that space, that's 60 degrees. I'm going to put that on my drawing in a different color so that I know that I calculated it. They didn't give that to me. I figured it out. So in case something goes wrong, I can go back and look at the things that I calculated myself. So we have 2 parallel lines cut by a transversal. If this is 60 degrees, then we know this piece right here is 60 degrees, right? Because alternate interior angles are equal. Remember that from geometry? So this little piece right here, this piece right here is 60 degrees, that angle measure. All right. So I'm going to go over here. Let's just I'm going to do a drawing. We need to find x. We know 30. We know 45. Sure would be helpful if we knew this angle measure right here, wouldn't it? I know part of it. Part of it is 60 degrees, this part. Is it possible for me to find this other part? It is, isn't it? Because this distance right here would be 180 degrees, right? If I rotated from here to this north line, that's 180 degrees. But I've gone further to 230. So what does this little angle have to be? It has to be 50 degrees, right? It has to be, so I would do the 230 minus the 180, and that would give me this angle measure, which we said was 50. So this is actually 50 degrees. Okay, we okay with that? So now I know this angle, right? This angle is going to be the 50 plus the 60. So this angle is 110 degrees. So I'll pause here for a second. Are we okay? Okay. So now I'm going to use, this is where everything we've learned come together, right? We need to know how to do law of sines, law of cosines. We're going to have to do area. You know, it's just all comes together. So what do we do? It's your choice. I'm going to do law of cosines because I have side, angle, side. I'm going to do law of cosines. That's what would be best with side, angle, side. So let's do that. So I have x squared equals 45 squared plus 30 squared minus 2 times 45 times 30 cosine of 110 degrees. Okay, so that is my law of cosines. And of course, this is a calculator lesson. So we would put all that information in our calculator. We're going to get a number. Then we would square root it, right? I'm not going to go through the calculator input. I think we're all good at that. So we put all this in and then square root it. And you should get that x is 62.0359. Or if we're going to round, it's 62.036 nautical miles. So that's the answer to our first question. That's how far the ship is from where it originally started, is 62.036 nautical miles. Okay, we okay with that? The second question is, what is the bearing from its starting point? From its starting point. We need to go to the from. Okay, and I'm going to redraw again. I'm not going to draw over my picture because that's confusing, and I may mess up the bearing and may have to draw it again. So let's just redraw. So the from, where did we originally start from? That was right here, wasn't it? That's the from. So let's draw. I'm going to draw another version of this triangle. Here's the from. Remember, we go to the from, we put a north line there. And then I rotate, so I go above my from on the north line and I rotate till I hit the path they're talking about. They want, where is it from its starting point? So it's right here right now, right? That's where it is. So I'm going to go this way. This is my bearing. Okay, I redrew it. That's my bearing. That's the angle measure I need to find. Now let's compare my drawing to my original drawing and see what information we have. So what do we know? We don't know that, but we do know that from here to here, that's 300 degrees, right? We know that. So is it possible for me to find this angle measure? Yes. If I were able to take 300 and subtract this angle, wouldn't I get that angle measure? Right? I'm going to call this alpha. You can give it whatever name you want. That angle, I'm just going to call it alpha. So the bearing would be equal to 300 minus alpha. We agree? 300 degrees minus alpha would give me my bearing. So now my job is to go back to the triangle and figure out if I can find alpha. So we go back to our triangle, and I think we can. That's not going to be, right? We just need to find this angle measure. So I'm going to use law of sines. So we have sine of 110 over, that's 62, and I keep all those numbers in my calculator, right? I stored it, equals sine of, alpha over 45. So now I need to find alpha. So we've done this lots of times before, right? We know what to do. We'd cross multiply. We would cross multiply, then we would take the arc sign, remember, of the number that we get. So I cross multiply and take the arc sign, and I get that alpha is 42.9719 degrees. Okay, that's my alpha. So now let's go back to our bearing calculation. So the bearing is going to be 300 degrees minus 42.9719. You know, we'd have all those numbers. So we subtract those and we get that the bearing is 257.028 degrees. And that's our bearing. Okay, how are we on that example? We okay? Okay.